So hey guys, welcome back. To Advent of Code Day 1, and so we're going to be solving the Day 1 puzzle. I think Day 1 is going to end in like an hour or so, so I don't think this is going to be useful if you want to keep up with the competition, but if you still want to see how I did and stuff, then this will be good. So Advent of Code happens every year, and this is my first time participating in it, and this is really cool. So I'm going to be coding in Python. So let's get started. Yeah, why wait around? So day 1, Trebuchet. Something is wrong with the global snow production and you've been selected to take a look. The elves have given you a map. On it they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations you need to check all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So you don't need to read this. You own the main text starts here. The newly improved calibration document consists of lines of text. Each line originally contained the specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single two-digit number. For example, so it's 1, A, B, C and 2. So 1, 2 becomes 12 because first digit and second digit becomes a two-digit number, right? So the first value is 12, right? And then you have PQ3, SGU, 8, VWX, so 3 and 8, 38. And then 1, 2, 3, 4, 5. Here there's first digit is 1, last digit is 5, so it becomes 15. And then in Trebuchet that's only like 7 in between. So 7 is the first digit and the last digit, right? So it becomes 77. So we'll take this. I already have it in smallpuzzle.txt. So how we're going to solve this is something which is I think very simple. All we need to do is go through each line, and on each line we go through each individual character, and in each individual character we check if the character is numeric. If it is numeric, we'll add it to a temporary list, which then get adds to like a main conglomerate list, and then in this conglomerate list we first go through the conglomerate list. Wait, before that I'll show you how that looks. So let's just print num list. So see, so it's 1 2 3 8 1 2 3 4 5 and 7, right? So we already saw this. So it's 1 2, so the first is 1, second digit is 2, and then 3 8 and goes on, right? Now from this what I'll be doing is I'll go through each of these individual lines, and on each line I'll find the first digit, the last digit, and then I'll combine them to get the integer form of the two-digit number. Then I'll append it to the, I'll add it to the sum. So we get 142. So the answer is 142. Now my puzzle will be different from your puzzle, so this number is actually it's not at all useful to you, so don't worry about it. But this is how you can solve the first part. Now coming to part 2, the calculation isn't quite right. It looks like some of the digits are actually spelled out with letters. 1 2 3 4 5 6 7 8 and 9 also count as valid digits. So how we solve the first problem is not radically different from how we are going to solve the second problem, but we are going to build on top of it, right? So what they're saying here is like we have individual numerical numbers, but also like word form of the numbers. So there's 2 and 1 and 9, right? So it's 2 1 9, the first digit is 2, the last digit is 9, so it's 29. Therefore 8 2 3 is 83. A B C 1 2 3 X Y Z becomes 1 and 3, so it becomes 13 and such, right? So first what we're going to do is we're going to copy the whole thing, and we're going to we're going to clear out the small puzzle.txt. One second. Now we can go to temp.py, and then one method I use for solving this is like a sliding window, but there's probably other methods too. If you think that's a better method, then let me know, and if you think mine was good, let me know too, because I don't know, right? So how we're going to solve this is pretty simple. So let's say there's 1 2 1 3 6, right? Now previously we used to go through each and individual character and check if it's numeric, right? So we'll keep that logic because numeric numbers might exist too, right? But on top of that, what we're going to add are 3 sliding windows. So first sliding windows gets activated when number is greater than or equal to 3, and it only checks for 3 letter numbers. So what are 3 letter numbers? So 1, 2 and 6 are 3 letters. 4 letter numbers are 4, 5 and 9. 5 letter numbers are 3, 7 and 8. So the first sliding window gets activated when number is equal to 3, and then we'll have a second sliding window which gets activated when n is equal to 4, and the third sliding window gets activated when n is equal to 5. And then these sliding windows, they slide. So for each character we keep on checking if it fits our 3 sliding window or 4 sliding window or 5 sliding window, and if it does, then we'll append it to the num list, right? So I'm going to comment this out, and we're going to add the last piece of logic. So I've enumerated it, so I'll get the number. So if, let's say, if num is greater than equal to 3, and you know what, I can combine this, and we have a line of num minus 3 is to num in, let's say, 3 letter, then we templist dot append 3 letter of line of num minus 3 is to num. Now we're going to have the same logic but for 4 and 5, so I'm going to yank it, I'm going to paste it. I think I changed everything, maybe I missed something. Well, I can't see, I'm just going to assume I changed everything. So this sum logic is going to be the same, so I'm not going to touch that. So we get 281, let's check. It's 281. So we solved it, guys. So that was the sliding window method for solving it. Maybe if you have a better method, let me know. So day 1 is done. So happy coding. See you the next one. Peace.